What is gravity? No, seriously, what the heck is gravity?
Well, you know what? As soon as I heard this term gravity, I instantly think about the guy who thought about this a lot. Well, you probably guessed it right. It is the Isaac Newton, who is the man behind the story that goes like he was sitting under a tree and unfortunately it was an apple tree. And an apple fell on his head, and without thinking about it too much, instead of eating it, he just thought about it, and he kept thinking about it and made a lot of research on it. Why didn't this apple go up in the air? And finally he came up to the conclusion that there is some kind of force which the ground is applying to each and every object on the planet, which is making them to fall towards the ground. And that's why the apple fell down and didn't go up in the air. But this is a well-known and pretty boring story about the gravity that everyone knows. But we don't actually know what is gravity and how the Newton defined it until we go to the class 10th or 9th or even way back to the 8th. Well, in this video, I'm gonna explain you the term gravity and how Newton defined it. So let's get started. Newton studied about the gravity a lot. Throughout that study, he concluded that every mass in the universe attracts every other mass. So if there are a couple of objects A and B, then they'll end up attracting each other. And it really depends on the mass. That means if you put a larger mass in front of smaller mass, then smaller mass will get attracted to the larger mass. Newton observed this and he started his calculations on it. And the formula of this attraction that Newton gave us is F equals G m1 m2 by r squared. And the value of G does not change no matter where you go on the planet Earth. That's why it's called the universal constant. But with this logic, we should be attracted towards each other. But that doesn't happen at all, does it? Or any other non-living object doesn't come towards us on its own. But what we're not considering here is the Earth and the space. The Earth comes into play here. The Earth has the largest mass as compared to any other object on the planet. The Earth will attract every object which is in its gravitational field. That's why every living and non-living thing on the planet Earth, regardless of its size, will get attracted to the Earth. Earth applies much larger force on those things as opposed to the force that they are applying towards each other. Well, this is just a simple introduction to the gravity. Let's understand this in deep. Newton put his 3 laws of motion, which are popularly known as Newton's first, second, and third law, respectively. His first law states that if a body is in motion, it'll continue to be in motion, and if a body is at rest, it'll continue to be at rest, until and unless an external force is applied. And there are a lot of real-life examples, like when you travel in the bus and the bus suddenly applies a brake, your body jerks in the forward direction. This happens because both the passenger and the bus were going in the straight path, and when bus applies the brakes, half of the passenger's body stops, but half of it's still going in a straight path. That's why you get a jerk while the bus applies brakes. Moving forward to the second law, which states that the rate of change of momentum of a body is directly proportional to the force applied, and this change in momentum takes place in the direction of the applied force. What does this mean? Well, it can be understood in a simpler way. All you need to consider is this: F equals ma. That means the force is equal to mass multiplied by acceleration. We can't really understand much with formulae, so let's understand this with an example. There are 2 masses. The first one is a larger mass. That's why you'll need much more force to move that object. And the second one is a small one. That means you'll need much less force to move that object. This states that to move larger mass, you need a larger force. Because you can see here that the acceleration of smaller mass is more than the acceleration of larger mass, measured from the initial position. Newton's third law states that all the forces between 2 objects are equal and opposite. That means if one thing applies a force, the other will do the same. In short words, Newton's third law can be stated as, for every action, there is an equal and opposite reaction, acting on two different bodies. That means force of A equals minus force of B. According to the Newton, if there are two masses, then they'll attract each other. But what will happen if there are multiple masses? In this case, the gravitational force experienced by one mass due to all other masses is obtained from the principle of superposition, which states that a gravitational force experienced by one mass is equal to the vector sum of gravitational forces exerted on it by all other masses taken one at a time. While learning gravity, another point to consider is the acceleration due to gravity. It's really simple, you can understand it by just your common sense. So, what is acceleration due to gravity? Considering the Earth as an isolated mass, if force is experienced by a body near it, this force is directed towards the center of the Earth with magnitude mg, and g is the acceleration due to gravity. The formula of it goes like F equals mg and g equals gm divided by r squared. On the planet Earth, the value of g varies by three factors: the latitude of the Earth, the altitude of the Earth, and the depth. Due to these three, the value of g changes from place to place. If a body is at height h above the surface of the Earth, then the acceleration due to gravity changes, and that change is given by g equals g multiplied by r divided by r plus h bracket square. In case where the height is small, the formula changes to this. The second one is the change in the acceleration due to depth. As we go deeper inside the Earth, the gravitational force decreases, and at the center it becomes zero. And this change is given by the formula g equals g multiplied by 1 minus d divided by r. The third type of change occurs when there's a variation of latitude. Due to the rotation of the Earth about its axis, the value of g varies with latitude. At the poles, the effect of g is negligible, whereas at the equator, the effect of rotation on g is maximum. In general, the value of acceleration due to gravity at a place decreases with the decrease in the latitude of the place. The acceleration due to gravity at a place on the Earth where the latitude is phi is given by the formula g equals g minus omega square r cos square phi, where the omega is the angular velocity of the rotation of the Earth. At the poles, the phi is 90 degrees. That's why the acceleration due to gravity is maximum. At the equator, the phi is 0 degrees. That's why the acceleration due to gravity is minimum. And the value of g phi is equal to g minus 0.0337 cos square phi. Thus, the value of g varies slightly from place to place on the Earth. Well, that's for it. We'll discuss the next part in the following video. If you found this video helpful and entertaining, please click the like button and subscribe for more of this content.